Measuring the Megaliths, a presentation by Neal. John delivered a lecture on ancient units of measure, from Egyptian cubits to megalithic yards, and the surveying of Earth in antiquity. He is the top living authority on ancient units of measure, also known as metrology. Recorded live at Megalithomania Conference 2006.
Okay, well, as you've just heard, the measurement system of ancient times is quite complex, but it's not complicated. It's all held together by a system of fractions, and it's all interconnected, and I'll endeavour to explain exactly how. Yeah. That's complicated, that's not. Yeah, this shows the simple integration of measure. And these were identified by Livio Catullo-Stecchini, who was probably the most famous metrologist. He wrote the appendix to Peter Tompkins' Secrets of the Great Pyramid, which is a wonderful book and very informative. And he came up with these measures, which I've portrayed as so. Now, the Mycenaean there is related as 15 to 16 of the Roman, and also as 9 to 10 of the Greek. And, of course, if you know anything about metrology, it's widely accepted that the Roman is 24 to 25 of the Greek. Well, I extended that slightly by the certain knowledge that the so-called Drusian or Belgic foot is 8 to 9 of the Roman. But then if you put them in this arrangement, the same as Stecchini did, then you can see that it's also 5 to 6 of the Mycenaean. Now, and these are the accepted values at this rate, you know, and they're all very exactly defined. Stecchini defined that from the grave circle of Mycenae, which is exactly 100 of those Mycenaean feet. Already we're beginning to see a certain pattern there, in as much as that we're getting square numbers, 3 3s and 9, 5 5s are 25, 3 3s are 9, 4 4s are 16, 5 5s are 25, 3 3s are 9. So we're seeing square numbers here, and this fact has escaped me. Now, you can extend these measures to all known values of feet. Now, I've used those measures there were what's called, what I've had to make up terminology that I've tried to make fit their character, you know, or their nature. But these are the same values, or not the same values, rather. My God, it's what? It's okay, one back. There we are. Now, here, I've identified all the feet that have the same classification value, which I've termed root, and this is how they are in terms of the English foot, which is how they're supposed to be read. Now, the Mycenaean then has become 0.9 feet. Now, the reason I've chosen this form of expression is I've taken all the feet that are related to the English foot there, which is also a value of the Greek feet. The Greek feet are, in fact, extensions of the English foot, because the English foot is one in a series, or the English foot is one in a series of what turn into the Greek feet. And all the other feet have the same multiplications. I'll endeavour to explain this as we go along. Now, this is how they appear, as like Common Greek then is 35 to 36 of the Greek English. And these two values, the English foot and the Common Greek foot, are pivotal to the whole structure of metrology. They relate to each other as 35 to 36 here. And Each of them relates to one or the other of the measures, and this will become clearer later. But this is the same method, two methods of expressing the same data. This is the same as that, but I've arranged it, as you can see, was in the original table, as suggested by Stokini. And this is how they all fit together. Yeah. And you can see that the Greek and the English fit most of them. In fact, all of them are connected to those two. No one measure is connected to all of them by a move of a single fraction. Now, it's even more pronounced now, being expressed like this, that these square numbers are coming up, 64 there, 9 there, 16 there. And it was John Michel who picked this out, actually. He used the values I've got. And he composed another table, which I'll show you in a minute. But first of all, a little elaboration on this. There's only 12 feet shown there, and they're, I thought, at the time, were pretty much the range of feet. And it's difficult to see from there. But I've cut some slats to be those sizes. And here they all are, all those feet. And you can see there's not a great deal of difference between them. And this is the feet of all nations. I don't know if you can see that very well. But there's not a great deal of difference in the lengths of the feet. And these are used as far apart as Mexico and Japan. And they all use the foot measure. But they vary for reasons which I'll endeavour to explain. Now, taking these square numbers that appeared so prevalently in the table, John Michel arranged them as so. But he used all the squares. You see, oops. He used all the squares. 3, 4, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 181, and so forth. And he found that there were every foot related to a square number. Now, at the time we arranged those, there are in actual fact from here, which is the Russian foot. You find it all over the place. I've just called it Russian. I've called these by these terminologies because they relate to the English or the common Greek foot by a single fraction. But this one, for instance, the one called Assyrian, is also Mycenaean, and they call it Italic and Etruscan, and there's hundreds of names for these feet, which has made the subject seem terribly complicated, when in actual fact it's very straightforward. Now, certain numbers we hadn't identified. There's one, but it is 6 to 7 of the Iberian foot. And the Iberian foot is 1/3 of the Spanish Fara. And the Spanish Fara, well, it's still used in lots of South American countries, and it's still used in Spain by artisans. They've adopted the metre as the legitimate value now. There's the Iberian foot, yeah. And 3 of those is 2.724587, which is the exact value of the Spanish Fara. And it's generated mechanically. You see how these numbers are all generated mechanically, and they're only visible in terms of the English foot. If you express this in millimetres, it would be completely invisible. You wouldn't see a damn thing. But because the English foot is an ancient measure itself and related to all the other ancient measurements in this manner, then ancient metrology is easily interpretable by using English foot. If you use metres, you'd be absolutely lost. You wouldn't have a clue what was going on. Now, we've recently found this one, 1.066 feet, a reference to it, a very solid reference. It's a reference by Flinders Petrie, who was probably the most engaged archaeologist you could possibly come across, and a tireless worker and very reliable with his information. And he found the cubit of that particular foot. 1.5 times that is 19.2 inches. And he found that precise value being used in the temples of Persepolis. And I've since found references to the same length being used in Githium in Greece. There's a metrological block there that has, it's a capacity block. It has capacitors cut into it. And reading the same article on the Githium block, it said that the cubit commonly used in Githium was 19.2 inches. Well, this is the foot of that cubit, because the cubit is 1.5 feet. Sometimes it's 2 feet. Now, you can see that's the smallest of what you might call the pes mathematica. And this is the longest pes mathematica. That is, these are all generated mathematically, and they're all values that they would use as standards of a foot. Now, there are lesser feet here, but they are also half cubits. That's half the 1.5 feet cubit. So they're 3/4 of a foot. That is 12 digits. Yeah. So that's here, here, and here, and here. They're all half cubits. And they also use 2 feet cubits. It's a very common measurement, 2 feet. And the smallest one is 1.8 feet. Therefore, when you're dealing with metrology, anything less than 1.8 feet is a 1.5 feet cubit. Anything more than 1.8, you'd have to divide by 2 to see what was its foot. Yeah. So it's very handy to familiarise with these tables. There's one more point I wanted to make there. The one that we've been talking about, the standard of Githium and Persepolis, is also still in common use. And it's on tape measures that are used by American carpenters. Every 19.2 inches there's a diamond marked, and they're to find out where stud marks are, because 5 of those non-load-bearing walls that involve stud work, that they would be slightly wider spaced. So every 19.2 inches, the same cubit is being used, but we don't have terminologies like cubits anymore. But we still use the identical lengths. Now, 5 of those, because that's the cubit of that is 1.6 feet. 5 of those is therefore 8 feet. So that they still have a very practical reason that these ancient units of measurement have, there's very good reasons for them. Now then, we'll move on a bit. If I'm going to press it in the right direction, that is. Now then, this tells us something about the integration of measure that we've already noted. This is probably the most famous drawing of canonical man that's ever been produced. And it's an absolute work of art. It's genius. Well, Da Vinci wasn't he? We know that. But he's drawn in a 6-foot square. Well, if he's drawn in a 6-foot square, if canonical man is 6 feet tall, and there's no indication in Da Vinci's work that he's 6 English feet, but he's divided up into cubits. There is a cubit, 1 cubit, 2 cubits. That's therefore 3 feet. There's the other cubit, and there's the final cubit. Well, there's a standard measure of a method of drawing a circle of the same perimeter as a square. Squaring a circle, it's an age-old problem. But here, if you draw a Pythagorean triangle there of 3, 4, 5, you draw the corresponding square, the triangle the other side, then the centre of that circle to the centre of that, would enable you to draw a circle with the same perimeter. And the ratio it gives you is 22/7. But the 3, 4, 5 triangle makes it 14, so it's a double unit there. So it's 14 by 44, 14 in diameter and 44 in perimeter from those numbers. And those numbers then would be half a foot, because that's 1.5 feet. That's a 3 feet. That would be 3 feet there. or 3 in number there. That'll be 4 in number. That's 5 in number. It's the basic Pythagorean triangle, and it's the building block of the universe, according to Pythagoras. So I've used that to illustrate another circle that you can draw. This is Da Vinci's circle here, and it's 24 Roman feet if your man is 6 feet tall, and he's 6 feet one of the other feet, you know. Then the circle that you draw from the age-old method that I've put here would be 24 English feet. So 24 Roman feet is the circle that Da Vinci drew. And if you draw the other circle there, it's 24 English, and that shows, you know, a very distinct geometrical relationship between canonical man and time-honored methods of drawing squared circles. Now, you have well-known measures here. That's 1.6363. It's therefore a cubit, a 1.5 feet cubit. And it would be a foot of 1.090909. And this is a Sumerian foot, which is 24 to 25 of the Royal Egyptian. This then is a 2 feet cubit here. More of that when we get to Stonehenge. But this then is your basic megalithic yard, or one of the megalithic yards. It's 2.7272 feet. And this is a step, but we'll come to this a bit later on. And his foot, because the Royal Egyptian relates as 8 to 7 of the English, then his foot is exactly a half of Royal Egyptian cubit. 2 feet would be 1.71428571. And you find this value of a Royal Egyptian cubit repeatedly used. So canonical man, his foot is 1/7 of his overall height. Now, all ancient measurements are subject to the same variations. Now, the variations go along the rows as 175 to 176, 175 to 176, 175 to 176. And I've had to give them some sort of terminology. And between the two rows, it's 440 to 441, 440 to 441, 440 to 441, and so on. Now, this simple from a root of number 1 multiplied by these values, this would be 175 over 176 squared, or 176 over 175 squared. And this is a precise value, the one that Stachini was using in the original small table that he drew. That's exactly the most widely accepted value of the Greek foot. Now, this is a root geographic value, and this would be 1/360,000th part of the degree on the Earth, at 38 degrees latitude, which is around 3/7 of the distance from the equator to the pole. If you take, oh dear, hang on, I've gone back the wrong way again. Now, if you take, it's gone a bit dippy. Now then, if we take this then, the standard canonical, I've called this canonical because from a multiplication from a root, 441 to 440 plus 175 to 176, there to there, is 1008, and that's a canonical number. And all of the foot values that you care to put in that position, any one of those foot values in that original table, all 19 of them that come from the bent table, the mathematical feet, any one of them that you put there are all subject to these multiplications. But this is how, from a root of an English foot, they progress into values of the Greek foot. This then is 175 over 176 over 175 squared, and is the precise accepted value of a Greek foot. So it's a root geographic Greek foot. Now, this particular one that is of interest to us is the exact value of the foot at our latitudes, 360,000ths of the degree at our latitude, or the latitude of Stonehenge is the 52nd parallel. And this is what our Royal Navy, at this value, reckoned was 360,000 to the degree, exactly that value, because our degree is 69.12 miles at this latitude. And 1/60th of that is the basis of the nautical mile, and it's 608.256. It's rounded for convenience to 6080, which is the nautical mile accepted in Britain, but its real value is 60802.56. And 1/60th of that then to be 1/2 of a degree. So 100 times that then is the exact length of the stylobate of the Parthenon. And it also governs the measurements that we find in Stonehenge, and I'll show you exactly how when we get there. Now then, these are all the possible feet and subject to their multiplication. So it's not very clear actually, but any one of these is a foot, and not all of them have been noted at these precise values, but enough of them to give by inference the existence of the others. But these are all the possible foot values. That's all the root feet and all the multiplications they're subject to. And like I say, it's complex, but it's not complicated. It's all very, very straightforward. But nobody's ever understood it before. I don't know why. Now then, I'll just run through a little bit about how scattered and seemingly complicated the evidence is. I found this in a book by Ordo et Mensura, which is a firm of a German sort of association who are all interested in ancient metrology. And this gives all the foot values of the cities of Germany at the time of metrication. Now, that's not the way I'd present the evidence. You know, I had to go through, and this is my methods. I had to go through, and damn it, I keep doing that. I had to go through and pick out all of these millimetre measurements, convert them to feet to make some sense out of it, and then give them their classifications. But when they're properly tabulated, so that you can see what's going on, this is how they'd appear. So I've taken all of the feet of the same value that I found used over Germany. Then I've put the cities where that feet was used, where that particular value of the foot was used. And these particular values of the foot, they're only for administrative purposes. It's for taxing, tithing, regulation. They're bureaucratic measures. And they don't mean a thing. I mean, say something's Egyptian or Assyrian or Sumerian. It's just the bureaucratic standard. All of these values were used by all cultures. And here you can see that this is the case. Here in Germany, we have the Belgic foot. And at that particular value, it's a root geographic value. And that's the precise value of the foot that we saw in the original table that elaborated slightly on Stachini's simple one. And then we can see all these ancient measures. This is so-called Common Greek. And this is the Olympic Greek, and this is the one that's used in the original tables. You know, it comes into one of these millimetre values. Now, these are the absolute values of these feet, taken from the mathematical construction of metrology. And this is how they've been expressed as millimetres by the bureaucracy of Germany when they went metric. Now they've rounded everything up, and you can see how narrowly they can form. You know, that they've just gone to the nearest millimetre, and this is so obviously the case. This is as they ditched ancient metrology, but when the metre was introduced, and this draws a hideous veil across the subject, expressing things in metres, you can't see what they are. But I've had to convert these all back into feet to see where they fit. There's an interesting little measure, actually. I should have dealt with that earlier. Samian, I've called it. It was a foot I'd dismissed and as unidentified. In fact, I hadn't really run across it. But it emerged from John Michel's construction the square numbers connected with the development of the measures. And then I found that Herodotus had claimed that the base of the Great Pyramid, which is 756 English feet, was 800 feet. So I've called it the Samian foot because Herodotus was from Samos. And then, as is so often the case, when you find one of these measures, you find it all over the place. And there it is, in use in Germany. Here, where is it? Here. So it's in use in all these cities of Germany: Bremen, Enger, Ostwalen, Westfalen, Gotha, Korn, Kum, and so on and so forth. And when you finally accept something as a measure, it seems as if you then find plenty of evidence for it. I'll go on from there a bit. I did these tables in millimeters and things because I gave a talk to these German Ordo et Mensura in October last year, and because I was trying to express things in English feet, went right by them. They never got a thing, and they're supposed to be experts mention metrology. They know nothing. They know absolutely nothing. Now, this is how it's complete folly to look for a single standardized measurement in any building at all, any ancient building, be it a Greek temple, be it a megalithic ring. You won't find that they're designed around a single unit of measure. Now, this is how all these different feet exactly fit Stonehenge, and this is just the feet. There is the lintel ring of Stonehenge. Very significant because it's 1/30th of the overall width, and there are 30 lintel stones all round. It's a metrological dream. It's a metrologist's paradise, Stonehenge. And this, of course, is how the standards would be kept in the monuments and the temples. And this is what people have always asked. How could nomadic people possibly maintain their standards? This is how, in the fabric of their monuments. And if they met up there, the scientists, every 4 years, every 8 years, whatever, from all over, then they could calibrate all their instruments from the stones that are standing there already, the length of a temple wall. This is how the measurements have been preserved from prehistory to the present at the identical values. Now, the inner diameter then is 14 then to 15 of the outer diameter of the lintel ring. And this is very significant. 14 to 15 is 1.07142, and that as a measurement is the root of the Belgic feet. And the Belgic feet is writ large here, writ large in Stonehenge, because all the measures in Stonehenge, here you can see, because the Greek foot here, 96 Greek feet of 1.01376 feet, and it's exact. Petrie measured Stonehenge very, very accurately, and he got it spot on. And that was the inner diameter he called the Pelasgo foot, the Pelasgo Roman foot he identified it as. And I've later seen the same reference to the identical value, which is 0.9732096. It's there. That's the inner diameter of the Stonehenge lintel circle. And the outer diameter is then 100 common Greek feet of 104,272. And the ratio that links them, of course, is 14 to 15. But in terms of our root English foot being multiplied by 101,376, all of these values are multiplied by 101,376 from the root tables of the ones that relate to the English foot by a single fraction, you see. So this would be the measure that governs Stonehenge, 101,376, which means it's built to standard Geographic. Now, this value here is the Geographic Greek foot on the very latitude upon which Stonehenge stands, and I find this highly significant. Dear, I'm running out of time here, actually, so I'll have to skip on. Oh dear. And then here is Stonehenge. This is one of John Scholl's diagrams. It's a pity he's not here to receive his views for all this. He will be here. But 17.28 miles is exactly a quarter of a degree. And it's the quarter of a degree that separates the latitudes of Stonehenge and Avebury. I don't mean closely. I mean exactly. This is what comes out of a study all the Bronze Age and Neolithic, is the nitpicking accuracy of these people in the dispensation of their monuments and in the precision of their layouts. This is just an aside here, because the stylobate here is 101,376 feet long, which is 1/2 of 1 degree. And this is meant to illustrate how it's foolish to look for a single unit of measurement around any construction, because the whole thing was about the preservation of integers. So you've got whole numbers in every aspect. They didn't have fractured numbers. And this is basically the purpose of ancient metrology and its complexity is the Pythagorean principle of perfect archetypes that exist beyond the material, and everything that becomes material strives after the perfection of the archetype, but of course never quite makes it. Everything's a little bit flawed. So that they had a whole gamut of numbers to express everything, and they're mathematically generated to express everything in integers. I mean, every man is 6 feet tall in one or the other of the feet. You know, that's the sort of thing. Yeah. I mean, that range then would be from about 5'3" to 7 feet. How neat, you know. But here you see Vitruvius, the Roman architect, gave us methods of deducing modules from the temple constructions, and 24.5 into the stylobate, or the peristyle there, which is the top step, which is the same as the architrave, is exactly 101,376 divided by 24.5. It's 4 common Greek feet at again, the standard geographic value. The same values that were used in Stonehenge are here, as large as life in the Parthenon. But all these other methods of finding the module. Here we've got the metopes and the triglyphs. This is how the frieze is divided up classically in a Greek temple. And together they make up a cubit. It's exactly that length. This is 1.1264. You find this number all over the place. For instance, on the Ashmolean man, he's exactly 6 feet of 1.1264 in his width. You know, it's a very famous statue, man outstretched with a Roman foot over his arm, 6:7 ratio again. You know, and it's exactly that value, and that value of that foot is also found on a metrological stone in Leptis Magna, a very famous stone. Anyway, better go on. This, then, is the nature of the megalithic yard. This is what a megalithic yard is. It's a step, and this is what its detractors have always said it was. It approximates to a pace of the Neolithic male. Of course it does. The whole thing's designed around the human body for human convenience. A step is the human body in motion, and this is how itinerary distances were measured in something we can all understand. A step is 2.5 feet, a pace is 5 feet, a mile is 5,000 feet. Mil passum, which is where we get our word mile from, it's simply 5,000 paces, 5,000 times 5 feet, or 1,000 times 5 feet, rather. Now, this is, if you want to say the megalithic yard is 2.5 feet, which of course it is, and Tom never saw that, but he did know that the megalithic yard is something that George was speaking about in his cut and ring markings and all that sort of thing on the stones. Tom deduced a measurement that was 1/40th part of a megalithic yard. Well, 40 digits, because there's 16 digits to the foot, is 2.5 feet. Yeah. So that's how the megalithic inch fits the megalithic yard. It's a digit to the megalithic yard being a step. And then all the old Greek values here, if you see, you know, a finger or a digit is a megalithic inch, a hand length is a quarter of a megalithic yard. You find this quite often in megalithic circles. The pygon or ream in 20 digits is half a megalithic yard, and the step is a megalithic yard. 2 steps, the megalithic fathom, 2 steps is a pace, and there you go. 10 hand lengths would be the megalithic rod, though the megalithic rod is not related to the megalithic yard as Tom thought it was quite. Because if you've got a 2.5 feet measurement, you can't have 2.5 then. You're going to be at some 3/4 thing, aren't you? It won't be a whole measurement. It won't be a sensible measurement. I'm going to run out of time here before we get up to the megaliths. Now, these are two values of the Belgic foot. They start at two different roots, so I don't want to complicate you with that. But these are all the possible values of the megalithic yard. Now, Tom stated there's a probability amounting to a certainty that a single unit was used in the setting up of these circles. And I propose to call this unit the megalithic yard. It's utter nonsense. It's utter nonsense. As we've seen from all the constructions of antiquity, no single measurement fits them all. If every single structure has more than one module in it in order to maintain integers. And you can see this from Tom's work on the megalithic circles. Here, 130 1/4, and 43 1/3 rods in the perimeter. No. The ancients always worked in integers, whole numbers, in both diameters and perimeters, and the maintenance of whole numbers on circular structures is maintained by the use of these fractions that separate them, 176, 175, 441, 440, but we don't have time to explore that either. But these are all the possible values in terms of English foot of the megalithic yard. And you can see they're Belgic and Sumerian feet. And the closest one that you often see to what Tom claimed is there, 2.7216. Now, this one also is written large in Stonehenge. That's a step of the Belgic foot. And you can find this value. There, it would be a standard geographic value. In Stonehenge, it's quite plain. Here, I think Martino's been through this, so we'll skip this. It pointed out how all the diameters point to other circles. Just nip back there a minute. No, we won't. All of those are stone circle sites in Canonical, and all those lines are directed at you from the way the diameters are lined up, and this is how they all are. Now then, I've gone into this circle a little bit to explain about the measurements in them. This guy who did this, he just gives the values in megalithic yards. Tom often does this, which is a damn nuisance because you don't know which megalithic yard he's referring to. But if you take that as being the Spanish vara, it has a very neat solution. You know that can't be right because a megalithic yard is 2.5 feet. You can't have 7.5 times 2.5 feet. You'd end up with some ridiculously complex, irrational number. So there is more likely to be the case. I have to wind up. Okay. Yeah, I'm sorry, I've barely started really. But well, I'm afraid that's all I've got time for. But it is a science. It is real. It was used in the ancient world, and fragments of it percolated down to the Greeks. And if the scientists want to use the meter, let them have the bloody meter. Leave us our God-given measurements. Leave it to the people who believe in God, because we're supposed to be in God's image, and they all spring from human for human convenience. So let the scientists get on with the meter. Give us our feet and inches back.
This has been a Megalithomania audio production. For more information, visit megalithomania.co.uk.